everyone. We continue our lesson for chapter 9. 9.3 Mutually exclusive events and non-mutually exclusive event. So how we differentiate? Okay, here an example. Some table tennis balls labeled from 1 to 9 are put in an empty basket. A pupil chooses a table tennis ball from the basket at random. Let T is the event of getting an even number. U is the event of getting a perfect square. V is the event of getting a factor of 9. So now we list down all the possible outcomes for S, T, U and V. Then we represent in the Venn diagram. Okay, we represent in the Venn diagram. So from the Venn diagram, we can see that T and V, there is no common possible outcome. So T intersection V is an empty set. T and U, there is one common possible outcome. For U and V, there are two common possible outcomes, 1 and 9. Okay, so from the diagram, we can say that event T and event V cannot happen at the same time. Means outcome for event T is for event T and V is for event V. There is no common and possible outcome for event T and event V. So event T and event V are said to be mutually exclusive event. A combined event T and V is known as mutually exclusive event if there is no intersection between event T and V. So we continue. Okay, table tennis ball labeled with 4 is the common outcome for both event T and event U. T and U, one common possible outcome, ball label 4. So event T and event U are said to be non-mutually exclusive event. Okay. We try self-practice 9.3a. In your textbook, a fair dice is rolled. A list of events is given as follows. Okay, so for sample space 1, 2, 3, 4, 5 and 6. P is the event of getting a number that is greater than 4. Q is the event of getting an even number. R is the event of getting a perfect square. So now we want to determine the combined event are mutually exclusive events or non-mutually exclusive event. So P and Q. P and Q, there is one common possible outcome. So we can say that P and Q are non-mutually exclusive event. How about P and R? P and R, there is no common possible outcome. So we can say that P and R is mutually exclusive events. Q and R? Q and R, there is one common possible outcome. So Q and R is said to be non-mutually exclusive events. Okay, number 2. An egg is chosen at random from a farm. K is the event of selecting a cracked egg. L is the event of selecting a grade A egg. M is the event of selecting a grade C egg. So K and L. K and L. K and L can be non-mutually exclusive events. Why? A cracked egg can be a grade A egg. Okay? K and M, also non-mutually exclusive event. A cracked egg can be a grade C egg. Okay? L and M. Grade A egg cannot be a grade C egg. So L and M is mutually exclusive event. So a tourist is selected randomly at Kuala Lumpur International Airport. R is the event of selecting a tourist from an European country. Okay, Italy, and so on. S is the event of selecting a tourist from an Asian country. T is the event of selecting a tourist from a Commonwealth country. So we look R and S. R and S, European country and Asian country. Is it mutually exclusive or non-mutually exclusive? So R and S is mutually exclusive event. Why? All Asian country is not a European country. Okay, R and T. R and T. Okay, some European country is a Commonwealth country. S and T also non-mutually exclusive event. Why? Some Asian country can be a Commonwealth country. Okay, so here in a general, here the addition rule of mutually exclusive event. Addition rule for non-mutually exclusive event. Okay, so for mutually exclusive event, here is probability of getting A or B equals to probability of event A plus probability of event B. For non-mutually exclusive event, probability of A or B is equals probability of getting event A plus probability getting event B minus probability of A intersect B. Okay, we try to verify the addition rule of probability. Oh, okay, two fair dice are rolled simultaneously. You still remember we have discussed the all possible outcome for when two fair dice are rolled simultaneously in subtopic 9.1. So now we continue. Q is the event that the total point obtained from the two dice is greater than 9. R is the event that the product of the point obtained from the two dice is a multiple of 5. S is the event that two equal points that on the two dice are obtained. Okay, as usual, first of all, we have to list down all the possible outcome for each event. So Q, the total point obtained from two dice is greater than 9. 4 plus 6, 10, 10, 5 plus 5, 10, 5 plus 6, 11, and so on. Okay, so R, the product of the points is multiple of 5, and S, that two equal points. Okay, so look at question A. P, Q, or R. Probability Q or R. Probability Q union R. We list down Q union R. Here there is 14 outcomes out of 36. 36 is all possible outcome when two fair dice roll simultaneously. Okay, then Q union R is 14 possible outcome out of 36. Then we simplify 7 over 18. Okay, just a simple check. Okay, Q and R is non-mutually exclusive event. So here the addition rule. So we can look by using addition rule, and by listing we will get the same value. Okay, B, probability of Q or R, Q or S. Okay, we list down all the possible outcome. Here 10 over 36. Then we simplify. Q and S also non-mutually exclusive events. Then when we use the addition rule, we will get the same value. C, probability of R or S. Okay, here 16 outcomes for R union S. Okay, R and S also non-mutually exclusive events. Okay, then we will get the same value of probability. So self-practice 9.3c. Okay, 7 cards labeled with letters G, E, M, B, I, R, A are put in a box. Then a card is chosen at random from the box. So by listing all the possible outcome, calculate the probability that the card chosen is labeled with a vowel or letter R. A vowel or letter R. So event, you have combined event, a vowel. So we represent A as event, a vowel, B as event, letter R. Okay. So both events, combined event, a vowel or letter R is mutually exclusive event. Okay. So A union B is EIAR, and probability of getting A union B is 4/7, means 4 from 7 cards. Okay, here I'm using addition rule or probability for mutually exclusive event. I get the same value. Okay, so 2 boxes labeled as K and L contain 4 cards labeled with the letters S, E, R, and I, and 3 cards labeled with the numbers 4, 5, 6 respectively. A card is chosen at random from each box. Okay. So by listing all the possible outcomes, calculate the probability of getting a letter S from box K or a multiple of 3 from box L. So you have 2 events, letter S from box K and multiple of 3 of box L. So as usual, I represent A and B for represent the event. A for getting a letter S and B multiple of 3 for box L. So here the all possible outcomes. Okay. A card is chosen at random from each box. Okay. So each box. We take one card. Here from box K, here from box L. Okay. Then from the all possible outcome, A union B is 6/12. Then we simplify 1/2. What is the possible outcome for A or B? A is getting a letter S and multiple of 3 or multiple of 3. Okay, here the possible outcome, we have 6, then 6/12, 1/2. Okay, 3. Okay, the probability of appointing Jesse as the chairman of the finance club and the head of the sport house are 3/8 and 2/9 respectively. So now we want to complete the Venn diagram. Okay, we want to complete the Venn diagram. Okay, 1/12. J intersection K here. So J intersection K. Use multiplication rule. 3/8 times 2/9. 6/72. Then we simplify 1/12 here. Then P only J. Probability of only J. Only J. Here. Only J. Only J. So from probability of J, 3/8 minus 1/12. Then we will get 7/24. P only K. P only K from probability of K minus probability J intersection K. And I get 5/36. B, calculate the probability of not appointing Jesse as the chairman of the finance club or the head of the sports house. Okay, so mean complement of J union K. Probability of complement J union K. Here. So for the complete probability is 1. Okay. Then 1 minus probability of J union K. Here is J union K. J union K. Okay. Then we'll get 35/72. Okay, thank you everyone for listening. I hope all of you can follow the lesson. Okay, you can try another question. Okay, goodbye. Thank you.